Professor Wong is a famous expert in cosmology and neutrino physics, and from the Australian University, New South Wales. You guys present a review on the neutrinos in cosmology. Well, during recent decades, I should say, or more short period, cosmology has become a precision science, and now you are using this new environment in cosmology and new data just to constrain neutrinos. What is the most important outcome for neutrinos if you just look at it from cosmology?
Most important outcome. Okay, well, I think it's very impressive that you can measure the neutrino mass. Laboratory experiments are able to do these days. I mean, cosmological mass bounds are easily a factor of 5, or maybe even 10 better. Yeah. So I think that's really exciting that you can measure something so small with something so large. Yeah.
And also the number of neutrinos?
Also the number of neutrinos, that's also very interesting, especially in view of the search for light sterile neutrinos. And again, cosmology is able to say something about the number of neutrino families.
I see. And what about the lower bound, the bound from below?
You mean a neutrino measurement? Well, I mean, at the moment we only have upper limits. That's only because the surveys that we are using are not large enough. But in the near future, what we expect is to have some more missions. So there's going to be a new mission, a space-based one, that will be looking at distribution of galaxies. And with that survey, that's called Euclid. It's
a new experiment.
ESA, Euclid mission. And with that new experiment, you could conceivably get a lower bound on the neutrino mass.
Probably it will be the first time when you bound from both sides.
Yeah, it's the first time you'll be able to bound from both sides. That would be very exciting because that would be actually a measurement of neutrino masses, and it will be the first one.
From cosmology.
From cosmology even. So it'll be very exciting to see how it plays out, especially with like Hutchin that's going on now in Karlsruhe and what they get. And
but they fixing from above.
They're fixing from above, but you never know. They might measure something. They might measure something.
The cosmology will say.
Yeah, if they find something and it doesn't agree with the cosmological result, then that would be extremely interesting.
Yeah, sure. So we're living in a very exciting.
It's exciting
period for neutrinos and for cosmology both.
Yeah, absolutely. Yeah.
Thank you very much.
Well, thank you.
Thank you.
Thank you.